Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x minus 6 to the power of x is equal to 4 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 4 to the power of x. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 4 to the power of x over 4 to the power of x. So then these two cancel out. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 1. Now, if I have something in the form a minus b over c, this can be written as a over c minus b over c. So 9 to the power of x minus 6 to the power of x over 4 to the power of x, that can be written as 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x. This is equal to 1. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 9 to the power of x over 4 to the power of x, that's going to equal 9 over 4 to the power of x. And 6 over x over 4 to the power of x, that's going to equal 6 over 4 to the power of x. Now 6 over 4, the greatest common factor of these two is 3. So 3 times 2 is 6. Or sorry, not 3. The greatest common factor is 2. 2 times 3 is 6, and 2 times 2 is 4. So 6 over 4 simplifies to 3 over 2. And we still have 9 over 4 to the power of x. Now for 9 over 4, 9 is equal to 3 squared, and 4 is equal to 2 squared. So I have 3 squared over 2 squared to the power of x minus 3 over 2 to the power of x is equal to 1. Now, remember, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 3 squared over 2 squared, that is going to equal 3 over 2 squared, and we have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And these two are interchangeable, meaning this is also equal to a to the power of n times m. So if all of this is true, then this must mean that a to the power of m to the power of n is equal to a to the power of n to the power of m. So right here we have 3 over 2 to the power of 2 to the power of x, and that is going to be equal to 3 over 2 to the power of x to the power of 2. Then we still have minus 3 over 2 to the power of x is equal to 1. Now I'm going to let 3 over 2 to the power of x equal the variable u. So now I have u squared minus u is equal to 1. And now I can subtract 1 on both sides, so I get u squared minus u is equal to, u squared minus u minus 1 is equal to 0. So now I have a quadratic equation, and I can go ahead and plug this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have, if I plug these values in, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. All of this divided by 2 times 1. Now negative of negative 1 is positive 1. So I have positive 1 plus or minus the square root of negative 1 squared is 1, minus 4 times 1 is 4, 4 times negative 1 is negative 4, divided by 2 times 1 is 2. This is equal to 1 plus or minus the square root of 1 plus 4 over 2 is equal to 1 plus or minus the square root of 5 over 2. So u is equal to 1 plus or minus the square root of 5 over 2. Now remember, we set u equal to 3 over 2 to the power of x. So right here we have, this is actually two solutions. We have 1 plus the square root of 5 over 2, and we have 1 minus the square root of 5 over 2. So let's start with 1 plus square root of 5 over 2. So I have 1 plus the square root of 5 over 2 is equal to 3 over 2 to the power of x. So what I'm first going to do is I'm going to take the log of both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus square root of 5 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would equal b times log a. So now I'm going to move this exponent x to the front of the logarithm. So now I have x times log 3 over 2 is equal to log 1 plus square root of 5 over 2. Now, I actually took, when I said log on both sides, this was to the base of 3 over 2. So if I have x times log base 3 over 2 of 3 over 2, these two will simply cancel out, and this is also base 3 over 2. And I will have x times 1 is equal to log base 3 over 2 of 1 plus the square root of 5 over 2. So now this means that x is equal to log base 3 over 2 of 1 plus square root of 5 over 2. Now, this is the same thing as x is equal to log 1 plus square root of 5 over 2 divided by log 3 over 2. And if I have something in the form log a over b, this is equal to log a minus log b. Meaning log of 1 plus square root of 5 over 2, that's going to equal log 1 plus square root of 5 minus log 2, and log 3 over 2, that's going to equal log 3 minus log 2. Now this is equal to 0.51 minus 0.301 divided by 0.4771 minus 0.307. And if you simplify this, you get x is equal to 1.868. Now we got to take a look at our second equation, which is 1 minus square root of 5 over 2. Now if 3 over 2 to the power of x is equal to 1 minus square root of 5 over 2, well, this is actually not possible because the 1 minus square root of 5, that is going to be a negative number. And you can't take the power of a positive number and make it a negative number. So meaning this has no solution, and our only solution is x equals 1.868. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x plus 3 is equal to 3 to the power of x plus 2. And we want to find our value of x here. So the first thing we are going to do is we are going to divide both sides by, well, before that actually, sorry. If I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, we have 2 to the power of x plus 3 and 3 to the power of x plus 2. 2 to the power of x plus 3, this would equal 2 to the power of x times 2 to the power of 3. 3 to the power of x plus 2, this is going to equal 3 to the power of x times 3 squared. Now I'm going to divide both sides by 2 to the power of 3, as well as 3 to the power of x. So now I have 2 to the power of x over 3 to the power of x because these two cancel out. And for my right hand side, these two cancel out, so I'll have 3 squared over 2 to the power of 3. Alright, so now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 2 to the power of x over 3 to the power of x, this is going to equal 2 over 3 to the power of x. And now I'm not going to do anything to this. This will still remain 3 squared over 2 to the power of 3. So now what I'm going to do is I'm going to take the log on both sides. So now I have log 2 over 3 to the power of x is equal to log 3 squared over 2 to the power of 3. And if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So for log 2 over 3 to the power of x, I'm going to use this property and move my exponent here, x, to the front of the logarithm. So now I'm going to have x times log 2 over 3 is equal to log 3 squared over 2 to the power of 3. Now I'm going to divide both sides by log 2 over 3. So then these two cancel out, and I have x is equal to log 3 squared over 2 to the power of 3 divided by log 2 over 3. Now if I have something in the form log a over b, this is equal to log a minus log b. So for log 3 squared over 2 to the power of 3, this will equal log 3 squared minus log 2 to the power of 3. And for log 2 over 3, it's going to equal log 2 minus log 3. Now remember the property that states if I have something in the form log a to the power of b, this is equal to b times log a. So I'm going to use this property for both log 3 squared and log 2 to the power of 3. So I'm going to move my exponent to the front of the logarithm. So now I have x is equal to 2 times log 3 minus 3 times log 2 divided by log 2 minus log 3. Now, log 3, this is equal to 0.4771. And log 2, this is equal to 0.301. So now I have x is equal to, if I substitute in the values for 0.4771 and 0.301, I get 2 times 0.4771 minus 3 times 0.301, and I'm dividing this by 0.301 minus 0.4771. Now 2 times 0.4771 is 0.9542 minus, now 3 times 0.301 is 0.903. Now I'm going to divide this by 0.301 minus 0.4771 is negative 0.1761. And this is equal to 0.0512 over negative 0.1761. So finally, x is equal to approximately negative 0.2907. Now, to check, I'm going to plug in the value for x into the original equation. So I have 2 to the power of x plus 3 is equal to 3 to the power of x plus 2. And remember, x is equal to negative 0.2907. So now I have 2 to the power of negative 0.2907, which is equal to 3 to the power of negative 0.2907. And I forgot the plus 3 and plus 2. So now negative 0.2907 plus 3, that's going to equal 2.7093. And negative 0.2907 plus 2, that is equal to 1.7093. So now, if you plug this into a calculator, you get 0.5400, which is equal to approximately 0.5394. And these two round up to each other. So 6.54 is equal to 6.54, and because this is right, our solution is right as well.